Hello, I'm Jason Marsh, and I'm the founder of Flow Immersive. This is a project we did for KPMG, which is looking at visualizing barriers to EV adoption, and it was for a specific transportation infrastructure summit. KELVIN is the name of their tool, which is the KPMG Electric Vehicle Infrastructure Tool, supporting holistic programmatic planning for clients looking to fund or deploy EV charging infrastructure. So the start of the supply chain for electricity for electric vehicles is the power plants. So in this example, we can see each of the different kinds of power plants that are on across the country. First, let's take a look at which states have more renewable power plants, more on the West Coast and some on the far East Coast. And also take a look at which states have less renewable power plants. A lot of the middle country, certainly Alaska, but still a good mix on the far East Coast. We can isolate any specific set of plants. So maybe take a look at nuclear plants, for example, and see how those are distributed across the country. So certainly more back east, only a few west of the Mississippi. So you can click around and explore the data for your own interest. Here we placed two data sets on top of each other. First of all, let's just show the residential electricity rates, which is based on the height. You can see that something like Alaska has very expensive rates, California, certainly Southern California, and also on the East Coast. Then in the middle of the country, rates are significantly less. So prior to coming into this presentation, I asked the AI to filter to just these three states, Texas, California, and Pennsylvania. You can actually really see the delta here. It's a lot of low-cost energy sources in California, yet they have some of the highest rates. That probably points to some regulatory challenges or something like that, where you can see the much lower rates in Texas, even though they have a pretty good, more petroleum, but also a pretty good mix of petroleum and renewable sources, and Pennsylvania, similar kinds of low rates back there. So one of the important things is range anxiety for EV owners. So seeing all the different charging stations and the density of those, certainly very high density on the two coasts, not quite so much density in some parts of the upper West, even Texas, Oklahoma, areas like that. With the AI, you can actually select 2 points, ask it to select the first point and say mark this point, and select the second point, tell me the difference from the prior point I selected, so you can see that kind of range anxiety right off the bat. Remember this location for the first point. Now I've selected the second point. The distance between them says about 94 miles. So government agencies have designated alternative fuel corridors. For example, we can see that the interstates have a pretty good crisscross of corridors that have been identified that should have charging structures. You can see states have done a good job of also identifying corridors such as California, Florida, not so much in the middle of the country. Okay, so once you have the power generated, you need to get it to where the people need to charge their vehicles, and then you have to take a look at transmission lines. Transmission lines are actually a huge bottleneck in the whole EV charging infrastructure. You can see some of the really high voltage power lines, particularly some coming out of Monterey. We're going to talk a little bit more about that. So let's take a look at the multidimensional relationships, just focusing on Northern California, a little bit in Nevada here. We can filter out, so we can turn on and off the transmission lines, the alternative fuel corridors, maybe just looking at power plants for the moment. We can see that there's quite a few hydroelectric plants on all the streams coming out of the Sierra. But battery plants, we have one very large battery installation again in Monterey. We're going to come back at that. you can click around through this through these different buttons to turn off the different aspects of the infrastructure required to get electricity generated, and all the way to the garage where the EV can be charged. So let's get a little deeper into the story here, where there was actually some uh, two different fires that occurred at these plants, at this battery plant in Monterey. And that led to some environmental damage, and really helps reiterate the challenges with siting of batteries, because batteries are a massively efficient way of taking care of solar power through the night, and getting it to cars which are typically charged in the middle of the night. So batteries are very important. In general, batteries are much safer now than the ones that were had an issue that caught fire here, but still has left up some really challenging regulatory issues, resulting in where you can site some of these grid level battery plants. And it's interesting to compare California with Pennsylvania. Pennsylvania has several large nuclear power plants. It has lots of large transmission lines to make it easier to get the power around the state. So a lot more options for power in Pennsylvania, and a pretty good distribution across the state for charging stations and power distribution. Thanks for taking a look. I'm glad you could see what Flow can do to help you understand a whole bunch of different layers of information around the charging EVs.